Again, hello everyone, once again. My name is Nikolai Koldanov, and we're going to do this introductory Python course here today. First of all, I would like to thank Climate Dynamics section from Matplotlib Institute for providing us this opportunity. And if you're a student and maybe interested in climate dynamics and the ocean modeling and atmospheric modeling, you can have a look at our webpage and on Alfred Wegener Institute and see what we are doing and maybe apply for some of the positions or internships in our department. I'm gonna give this introductory course and for about like 2 hours. Usually it takes 2.5 hours, including questions. I'll try to be not very long. I will try to make it so that is most useful for people who already have some experience in programming. That we don't gonna dive really deep into the internals of Python, let's say. I just want to show you where to find the information, how to start, and what kind of capabilities you will have when you use Python as a geoscientist. So that's the main purpose of it. I'm not really sure if you will be able to like start to write really heavy duty applications after this course, but at least you will know how these things looks like and where to maybe find information. First, maybe just go to the course webpage. You all should have this link already. If you go to the course webpage, if you scroll down, this is usual for GitHub projects, you can see the installation instructions. What you can do, well, in principle, if you already have these things installed, if you follow these instructions, it's nice. You can follow along with me. You can use these instructions afterwards and install Python and necessary modules afterwards. There are instructions for Linux and Mac. There is also instruction for Windows. I updated it a couple of hours ago because people said that the links were broken and there was some problems. Although I'm unfortunately not really familiar with the Windows kind of installations and any type of work on Windows. I didn't use Windows for quite a long time. So you have to, with this you own your own sort of, but I try to find a couple of tutorials that explain you how to install things. So there's a nice video tutorial that I link here. And in principle, from what I saw, the situation in Windows become a little bit better than the last time when I tried to help somebody to install something on Windows. So you should be able to do it by yourself. But again, well, don't expect me to solve a lot of Windows problems, let's say, afterwards. Also, during the course, we will not be able to solve your technical problems, unfortunately. So it's different from the personal course where we have usually like about 20 people and I can go to everybody and actually solve their problems with installation. You would probably, if you have technical problems, then you probably have to solve it afterwards. Maybe drop me an email or just make an issue on the GitHub. So if everything is working for you, I'm really happy. If it's not really working, then let's wait until the end of this course. Okay, I see in the chat that the Windows instructions work fine, but only when the folder name was without spaces. Well, yeah, that's something that we have to look afterwards, probably. Okay, let's start. I think, and start with why Python. I think most of you kind of know a little bit about what it is and interested in using Python. That's why you came to this course. Just a brief brief list of why I think it's nice to use it for geoscientific applications. First of all, it's easy to learn, easy to read, and fast to develop. So comparing to some very kind of low-level languages like C, C++, you can put together your prototype very quickly, and that's important for us as a geoscientist, because we have to test our hypothesis fast, right? And most of the time, just 99% of them will be thrown away anyway. It's free and open source. So compared to MATLAB again or IDL, you can actually share the code with other person, and you can expect that this person can just install the Python and repeat your research, let's say. It's multi-platform. It works on all three major operational systems, Windows, Mac, and Linux. There are some packages that doesn't work that well on every system, but they are minority right now. And one of the very important things is that it's a general purpose language. For example, MATLAB is a nice language, but it's sort of narrowed to the matrix operations, although you can do a lot of things with it as well. With Python, you can do whatever you want. So you shouldn't leave the language if you want to download the data, process the data, visualize the data, and then serve the data, this data in interactive mode afterwards somewhere on the web, and using some server side technology. All these things can be done in Python. You at least can write a prototype of all these things in Python, and then maybe if you have some performance issues, you can rewrite parts of it on some different technologies, but initially you can do everything in Python. There are some downsides as well. Although this list was written some years ago, and these downsides become less and less important. First one is there is a smaller legacy code base. This becomes less and less valid statement, because there was a boom in Python development in scientific applications of Python in the last few years, and the amount of code that was written for Python is actually very big right now. Although it still doesn't compete that much in scientific world with Fortran, because there are some very kind of basic stuff still written in Fortran, still used in Python in a way that is just compiled and reused in Python. So right now, there's a big chance that if you need something, some methods or some type of visualization, you will find the code written in Python for you. Another thing that a lot of times comes up, it's that it's slow. And this is interpreted language. Yes, it's supposed to be like not as fast as Fortran or C, but there are ways right now to make it faster. And these ways are this Cython, Numba, and Dask. It's just several examples of the Python tools that can make your work very fast. There are some links here as well. Especially this Python in Earth Sciences. This is the paper that was written in 2012, and actually everything that they said there was true. Now it's like 8 years later, I can certainly say that it exploded, really exploded, and the Earth Scientist, the usage of Python. Again, there is a lot of resources, and there is a lot of packages that are available for you, ready to use in Python. Do you have any questions to this part? If so, just still drop the message in the chat. That would be the best way to communicate. The next chapter. Okay. Scientific modules and IPython. So first thing that you have to understand about like when people say that they do something in Python, especially in scientific world, is that Python by itself will not do a lot for you, right? So it's pure Python has a lot of capabilities included already, and you can do a lot of nice things with it still. But if you want to be productive, you would have to use some additional so-called libraries. Similar to MATLAB, I think MATLAB also have some modules and libraries, but Python kind of scientific infrastructure consists of all these libraries and modules. And there's still confusion between what people call libraries and what they call modules, but usually people mean more or less the same thing under this. So I will use this term interchangeably. And there are several scientific libraries for Python that are actually in the core of all the computations. And this library is listed here. So one of them is Numpy, and this is really something that is like without this library, anything serious with Python will not be possible. And this library provides this n-dimensional array for you. And this is similar to the variables that you have in Matlab, for example. SciPy library, it's a collection of some of the methods of different methods like Fourier analysis and so on, so forth that are very much optimized. The Matplotlib. Can you see my mouse? Yeah, thank you. So Matplotlib is a library that allows you to plot things. Ipython is enhanced interactive console, so it's similar to what you again have in MATLAB or IDL when you type something in your prompt, in the MATLAB prompt. So Ipython initially tried to be kind of sort of a replica of that, but then it becomes much bigger than that. SymPy is symbolic mathematics, but I personally don't use it, so we are not going to cover it here. And Pandas is, well, you can simply put it as the Excel on steroids or databases on steroids. So that's a package that allows you to analyze tabular data very quickly, very efficiently. I'm not going to cover the installation. Again, you can just follow the link and try it by yourself. I try to put as much information as possible. And we will just start with the Ipython. What is Ipython, why we need it, and yeah, how to use it, maybe just a little bit. So in order to be productive, you need a comfortable environment. If you just type Python, you get into this Python prompt, right? So you can have here you can perform some operations here and do some computation and so on. So that's one of the ways to interact with Python. You can do it in an interactive way. But that's not very, well, it's actually more advanced than it was before. For a lot of things, you need something more than a simple command line. And for this, people invented Ipython. And that's much more advanced interactive shell for Python. And most of the scientists, when they work interactively in the shell, they use this one. So let's say we do the same thing, but like we can have some additional capabilities. I'm not gonna load you with too much information. Just important to know that it's also a Python shell that is more advanced. Although we are not going to use it, well, right now. There is a question: how do you get course on the left? I have base there. Yeah, well, course is the name of this thing. It's the name of the environment. You can of the Conda environment. You install probably the environment from Conda, and the default name will be base. I just created this separate environment where I have all the things related to my course, and it's called course, and that's why I have this course thing here. Okay, that was the Ipython. Let's try to go back. But after some time, since 0.12, the Ipython actually provides something called Jupyter Notebook. And Jupyter Notebook is the thing that you're right now looking at. This is this environment where I'm working in right now, and what is shown on your screens is called Jupyter Notebooks. Jupyter Notebooks, as you can see, work in the browser directly, right? You started, and I hope that some of you were able to do this. You started on in your shell. in your command prompt, just say in Jupyter Notebook, and then the server, so-called server, start to run on your machine, and then you can access this the things that this server is serving by entering this this address where it's serving this pages to you, and then you get into basically well, interactive environment that is located in your browser, right? So this code that I'm going to execute now is actually executed on your machine in the, like, let's say in the sort of in this place where you started it at this prompt, but you see the results displayed in your browser. Again, not that important to understand the details right now. You just have to understand that there is these Jupyter notebooks. They're super useful. There's a lot of tutorials of how to use them, and a lot of work, scientific work in Python actually happens in this Jupyter notebooks. Why they are so popular right now? Well, first of all, I just going to maybe say that the notebook actually consists of cells, and if you open for yourself, then you probably see this this panel here. So it consists of cells. One of part of the cells can be text cells, for example, this code execution, and they are done with the Markdown language. And part of them can be you can just execute the Python code in them, and the result of this execution will be actually displayed to you down below. You can execute the cell by pressing Shift Enter or just hitting this run button. Both ways will work. Text can be, again, Markdown. So if you double click on the cell, you see the source code for this text, right? So if you know what Markdown is, then it will be pretty familiar to you. Then you can say Shift Enter, execute it, and this is how your text looks like. You can use LaTeX equations. Again, this is the source code for this LaTeX equations, and after executions, they are rendered. So the thing is that you can combine your code and combine your narrative or equations that you that you're trying to implement in one place. And the most important thing for me, at least, is that you also can combine plots, right? So you just do some analysis, change something, make a plot. You don't have to save it. You don't have to open it in a separate window. It's everything in one place, right? So you execute something and you see a result immediately down below here. You can also input insert the rich medias like YouTube videos. This guy is actually Fernando Perez. He's a founder of the Ipython, and I would say co-founder of Jupyter Notebooks. Very nice person, have very nice presentations. You can search him for his presentations online. Yeah, so this is what the notebook is in the nutshell. To run the notebook, again, this is listed in the installation instructions. You have to execute Jupyter Notebook in your command line. Somewhere you can download these lectures, of course, and run them. And now I will show you several things that will make your life in Jupyter Notebooks a little bit easier. Although again, we are not going to stop on them too much. Just want to show that they exist. So if you want to get help in Jupyter Notebooks, you just have to use the question mark. Simple question mark will open your this so-called pager. I have to move this thing a little bit. That gives you some information about the Ipython itself. So again, maybe for the newcomer is a little bit difficult to understand, but the environment where you execute your code right now looks like Jupyter Notebook, but then the code executed actually in the Ipython, which is then sort of translated to Python. You don't have to think too much about this long, difficult pipelines. You can just think about Jupyter Notebooks as your Python, right? So this is your Python, and you work in Python. But there is some additional things that you can do with your Python code when you work with it interactively in Jupyter Notebooks. So let's put it this way. So if you have some function, you can actually put a question mark next to this function and see the documentation for this function. It's also similar to what you do in Matlab. I think you have to type help or something like that. So let's make it a little bit smaller. The similar thing you can do if you just put your cursor inside of some function call, just pressing Shift Tab. So it's Shift Tab several times or one time, and you get this pager like popping up right here. So it's very convenient as well. So I use it a lot. Another important thing that you can do, you can access your operating system that you're running your notebook from the notebook. So you can say pwd, and this will give you back the path where you're located. And this pwd, like exclamation mark, means that execute this on the system level, and pwd is the shell command. Right now I'm running on the Mac. Will be the same on Linux, but for Windows, I don't know. Yeah, I don't really know the command. Maybe people in the chat can say what it is. NCDump, for those who knows, and Netcdf files will also work, for example, like this. So you don't have to leave again Jupyter Notebook in order to look at how your Netcdf file looks like. You just can execute these commands as well, just from this environment. Another thing that is important, well, not maybe that important, but is useful, is something I call magic functions. And magic functions allow you to add some functionality again to your Python code that you execute interactively. Let's assume we have some list of numbers, and I will tell you what the list is a little bit later, but just some collection of numbers. And you want to, that is generated with some function, which is called range in this case. If I would like to know how fast this function works, because it's important for optimization, I can say time it, starting with this % sign, time it, and then execute this command, and it will execute this command it's several million, it's 1 million times it will execute it to see what's the speed of this command. And of course, if you have something that is a little bit heavier than that, it will not be 1 million, it will be much smaller. You also have whos available, which is not a standard Python thing, but this is something that is familiar for people who use Matlab. Right, so you can see the variables that are right now available in your environment. Next thing is cell-oriented magic. In this case, we just put something in front of the line and then execute the line. But what if you would like to execute several lines? You can do it as well. You have to just put 2% signs instead of 1, and then you can. Well, I mean, in this case, this command for the cell has also existed, just named the same way, and you can calculate how much time it takes to generate this this list of numbers. Another useful command is this $% bash. For those who use Windows or Mac actively, or bash scripting, you can see that you can write a small bash script, or maybe not that small bash script, again inside this Jupyter Notebook, and it will be working. If you want to combine Perl somehow with Python, is also possible. So you can just use this Perl, and the things that are written in this cell will be interpreted as the Perl command. Write file magic command will actually output everything that you have in this cell into the Python. Well, it's not executable, but it's a Python script, right? So to the file that is named hello.py, and then you can, again, with the help of this time is a line magic command, right? So it's not applied to the whole cell; it just applied to one line. But you can execute this this file saying hello world. So what I'm showing here is that you can execute Python scripts, separate Python scripts, also from Jupyter Notebook. And again, this is the whos command that we have some additional variable here, I guess. Okay. Again, it's not yet even Python, so I'm sort of rushing for it a little bit so that you don't get bored too quickly. if you want to know about magic commands, you just execute this percent sign magic, and you will see a huge list of these commands available for you. And there is a link. Okay, we have one chat message. Well, just PWD without sign exclamation mark. It's also might work for you. Let's see. PWD. And the reason is that you like if there is no Python command that is similar to this, then it's gonna work. If I say PWD is my variable, which is 0, then PWD is not gonna work, but exclamation mark PWD is going to work, right? So that exclamation mark explicitly said execute the system command without well, guessing if it's a Python variable or system command. Okay, there is another question here. Does it make sense to have or create a special environment? Yes, usually it's better to create a special environment for the bigger tasks that you're doing. And the reason is that Python, one of the sort of disadvantages of Python is that its packaging structure is pretty complicated, right? That's why we have this conda that makes life much easier than it was like 5 years ago. And different packages interact with each other. One package can depend on tens or hundreds of other packages. That's why if you're doing something, some particular analysis, like okay, this is my package for like my work environment for biogeochemistry analysis. So it's better just to have all the packages that you know that work in this environment and just don't touch them most of the time. On Windows, you can replace it with. So I'm again reading from the chat with exclamation mark echo %sign cd %sign. Well, Windows shell, it's not my thing at all, so I cannot comment on that. Okay, let's finally, after half an hour introduction into Jupyter Notebook, get to some Python. Right. Again, gonna be relatively fast. I'm sorry about that because we have only like 3 hours allocated, and I try to make it smaller than 3 hours. I cannot really talk without breaks for 3 hours. So it's gonna be faster, and it's gonna be very basic. Okay, basic Python things. We have variables that have different types, but in Python we use something that is called duck typing. So it's mean if it looks like a duck, if it's makes sounds like a duck, then it's probably a duck. So Python will try to infer the type of your variable, and well, on the fly. Let's just clear all the output, otherwise it's not that much fun. So we assign 10 to some variable. We can look at this variable as just 10, and the type of this variable is integer. We have integer variables. We also can define float variables like this. So this will be 10.7, it's a float. The type is float. We also can define strings, and strings can be defined in this like this or like this. So these things are equivalent. There are some differences sometimes between these notations, these two notations, but they are sort of maybe not in the beginning will be super important for you. So you can define strings like this. Some operations are not allowed on different types. For example, A plus B. If you remember, A is 10, is integer, B is our string, so this one. A plus B, not gonna work. You cannot add integer to string. But some things are allowed, and you can multiply A to B. And that means that just repeat my string 10 times. This might be a sort of confusion in the beginning, and yeah, you just have to, with trial and error, get along with it somehow. Strings also can be combined. So here I have a string that it says guys walk into a bar, and then you can say B plus C, then you say, then there will be 2 guys walk into a bar. If we say plus B here, then it will be like this, right? So you see that it's the order is of course important. If you want to convert your integer to string, you can just use str, and then you have your 10 guys walking to a bar, right? Everything in Python is an object. Every variable, at least, yeah, well, it's everything, including numbers, let's say. But you most of the time think about variables and functions. So variables are objects as well. And this C, just remind you that it's a string that says guys walk into a bar. If you put the dots, then you can after the variable you can access things that called arguments. Well, I mean they called methods, most of them. So how you do it? How this thing popped up? You just type string again, type point after your variable, and then press tab, right? And you see all the methods that are available for you for this variable. By methods, that means that you can do something with this variable, right? It can be a function that can be applied to the content of this variable, or some additional information that is stored in this variable. So this is called attributes, methods, sorry, of your function. And we will just explore some of them. So methods basically default functions, again, that can be applied to a variable. You can say C upper, and then all your text will be converted to the upper to the capital letters. You can say title, your letters, the first letters will become big. You can say count, and it will count the number of A's in your string, and it's 1, 2, 3, right? It's 3 A's there. You can find where the beginning of some word is located, and this string can be can be dissected into individual characters, right? So it's starting with space and then G and so on and so forth. And the 11th character, and about numbering, we're also just going to talk in a minute. The 11th character will be in beginning of your intro. This is maybe right now sounds like not very important, but actually if you work with the data and with some crazy file formats from ASCII files, that can become very, very handy. If you need help on some of the methods, for example, this method find that we just used, you can just put this, the question mark, look at it, and you see what kind of arguments this method actually takes, and hopefully what kind of output it will give you. The same thing you will see, so let's close this one. The same thing you will see if you start to open the brackets, right? Then put Shift and Tab. You can put it 2 or 3 times. This is what will happen after a second pressing the tab, and this is about after the third pressing the tab. So this will think actually stays in your Jupyter notebook. So you can read it right here. So you don't have to open this pager that pops up from the bottom. Integer itself, you remember that our variable a, it's an integer, is also an object, and this doesn't have too many methods, but still have them. And you can say the bit length of this object, or you can combine methods to pipelines. I actually, unfortunately, didn't spend too much time on this in this course, but it's something that you might see a lot, especially in the dirty scientific code. You start to apply methods one-to-one, and what it means that we have a variable C that is this guys walk into a bar. We make a title out of it, then we count number of A's on the result of this function, then we count the bit length on the result of this pipeline, right? And what you get in the end is 2. It's very convenient because if you first for scientific analysis, and you will see examples down the road of this, because you start to to do something like a mean, and then you want to apply some, I don't know, filtering on it. And it's very convenient just to apply these things one by one. You just have to remember what kind of result you expect in this place. Yeah, okay, there are 8 questions. So make sure it's in 10 multiplying A to B. I also got the error message. Yeah, thank you, people who are helping other people in the chat. I really appreciate it. And get an arrow. Do you always need a new cell to perform a new calculation command? Not necessary. You can actually, well, I mean, you can say A equals B. Oh, well, A equals 4. Then you say B equals 5. And then you can have a look at this numbers, and this is your A and this is your B, right? So this will execute something and store it in the memory. Again, you can have a look at this who's, what is now available in your operational memory, let's say, or in the namespace, as it's called. And this is all your variables, right? It's also important to understand that the commands can be executed in different order. So you work in this kind of environment in your namespace, and then if you execute something from above, and then something from below, and then again something from above, this will not respect the order that you put it in the Jupyter notebook. It will respect the order of execution, right? As the order will be the order of execution, and sometimes it's make confusion because you forgot to initialize some variables and so on and so forth. So in this respect, you have to be a little bit careful. Open a terminal, set cd to miniconda3, run. Okay, thank you very much for answering again. Maraika, is very nice of you. No, you cannot do many lines in a cell. Then they are run top to bottom. What happens? Yeah, okay. Guys, I'm again very, very nice of you that you're helping other people. If yeah, I will try to look at the chat again, but if somebody can help the others, that's really nice. Okay, lists. Another data type, and list is just collection of some objects, right? In this case, list is the collection of numbers. It's just 1, 2, 3, 4, 5. Yeah, just put them in the list. List is defined by the square brackets. So if you put some collection of numbers, comma separated collection of objects or numbers or strings, then you define a list. The objects can be of any type. In this case, those are strings. You can combine the objects. You can have some strings and some numbers there, some numerical values. You can have even some operations that they will be executed. And by any type, I mean any type, right? Here I also put a list inside of the list. So, and this one is just a list inside of the list. You can access the objects in the list one by one by this indexing, and this is also will be familiar to people who use Matlab, but I think you use this curl, this usual brackets, and for Python to access the indices you use square brackets. So this will be our 0th element. And here there's important thing for people who come from other languages. From other languages where the computations start with 1. And I'm looking at Matlab and Fortran people. In Python, counting, not computations, but counting start from 0. And that means that the indices of these objects will be 0, 1, 2, 3, 4. Right? So if you want to get the second kind of object, you have to put the index 1. And this 4th element will be, you have to put the index 3. It's something that maybe caused some confusion in the beginning, but usually people just get used to it very, very quickly. And it's actually very convenient if you're thinking about loops and so on and so forth. You also can, since you return here a list, you can also substitute, like get some value from this list as well by using this kind of syntaxes. Yeah, so it's the first we get the third element from here, so this one, and then the fourth element from this list, so this will be number 5. You can access multiple elements using slices, so here's just again the repetition of your list, and you can say from 1 to 3. And here is again some peculiarity. From 1 to 3 means from 1 is here. So I mean, actually, your your indexing starts. Think about this numbers, not think about these elements not as the actual indexes, but about these elements. Well, let me put this. Let me start again. So if you say from 1 to 3, that's mean it's going from here to here, right? So these two. And how it counts? It counts, okay, from 0 is here between nothing, well, before the 1. My 1 is between 1 and 2. So this is the index 1 here in this slice. Then next one is between 2 and 3. And then my index 3 for slicing will be between this guy and this one. Yeah. So it thinks in this terms. That's why it's yeah, it looks like this. The rule of thumb and how most of the people think about it is you just say that when you do the indexing, you just don't return the last value, right? You can say, okay, from 1 to 3, that's mean I'm gonna say 1, 2, and third will not be returned. And this is just easier for you to grasp, and this is how I think about it most of the time as well. But there is a reason for this kind of notification in selection. Okay, there is one question. Any chance to tell Python to start counting from 1? This isn't really missing. It's not really no. No, I'm sorry, Raf. It's not not possible. Yeah, it's you have to somehow. Yeah, I know it's a pity, but well, I get used to it, and there are some reasons actually. I think I have a link here that discuss the reasons why. Maybe I don't have it anymore. Why you? Yeah, it's here. There is some discussion why 0 and 1. Well, why 0 is better than 1. Maybe I think you can have arguments of the opposite as well. But yeah, that's the way it is. I'm sorry. Okay, control structures. I'm not going to go into many control structures of Python. Just actually 2 of them: for loops and branches. And again, we are not gonna use them actually during the course. I just want you to let you know that they exist, and there are some, again, peculiar things that are important to understand. And one of the things, okay, let's start with the for loop. For loop looks like this. Just say for, then element in L, and our L is a list. So you can loop over the elements of something that have elements, right? That can be actually dissected into some smaller parts. At least can be dissected into smaller parts. For example, your string also can dissect it into letters, right? And you can loop over them. And you can, and here I'm just printing each of the elements. Important thing to see and to note here is that we don't have anything like and, like there is no such thing, right? How does Python understand that our for loop is actually over? It's understood by indentation. And indentation is very important in Python. It forces you to write code that is more readable, but in the beginning it will cause you a lot of confusion as well. And again, sorry about that, but that's something that you would have to get used to. And in the first couple of months, it will just drive you nuts, because if you come from other languages, you will forget to do this indentation right, and yeah, it will cause you some errors that sometimes are pretty hard to spot. Usually in Python, we use 4 spaces as indentation. 1, 2, 3, 4. Right? Some people use tabs, but it's not really recommended. Although it's a matter of taste, something that shouldn't happen is mixing tabs and spaces. That's the most terrible thing that you can do if you're writing Python code. If you stick to something, stick to tabs or spaces, but just choose one of the things. Here's an example that, well, that shows that this code is not going to work if you don't use proper indentation. You, in principle, can use 2 spaces and also will work, but you see it's becoming becoming red. Sorry, Jupyter doesn't like it too much because the 4 is a standard, right? So you will have this is the working code. Again, you can use you can do the for loops in a usual way, just creating some range of indexes, and then substitute during the loop this index variable with this list variable here. It's also going to work, but this is more elegant, right? If you know that there is some elements in your variable, then you can just go through them directly. And yeah, this range is just, I'm showing that this function range just generate you a sequence of numbers, right? So you can generate a sequence of numbers and just go through them. So this will be equivalent. So we can just put it like this. It works as well. Okay, branches. Also, your indentation is something that is important here, and this is just to show that branches exist. They look like this, and yeah, and they're controlled by indentation. I'm not gonna spend too much time on it because we're not gonna use it in this course. But this thing is important. Modules. So again, Python consists, well, not Python itself, although Python itself as well, to some extent. If you want to do scientific work with Python, then you have to use different modules, and these different modules, in order to work, they have to be imported, right? Pure Python will not do much for you. And there are few ways to import Python modules, and they can be very confusing for the beginners because people make different ways of importing possible, since, well, some people like one way, some people like another way, and people like to have convenient tools, not the tools that are best suited for the beginner. So that's why they have several ways to do one thing. In this case, here we see the most common way. You just say import and the name of the module, right? And this will import the module requests for you. Requests has a lot of different functions inside, so you can access them again by putting dots and then tab. And you see there's a lot of functions that you can access from this request module. But the function that we need is this get function. We would like to get the HTML response from the fesom.de website. And fesom.de is a very interesting website that describes the model that our section is working on. So if you're interested, you can have a look. But you can substitute it with any website of your choice, I hope. So we would like to use only this function get. How to access this function? You say requests, the name of our module, and dot get, the name of the function. Then provide the argument to this function, and you can have a look what kind of arguments it expects. It expects URL, and then some parameters and some keywords. So the most important is you have to provide the URL. And then we will have a look at what this response show us. Well, I mean, we can actually remove this thing. So the response by default will show you that it's returns you 200, which means everything is fine, and the headers of this website looks like this. You see that we don't need the whole, for this simple operation, we don't really need all of the functionality of request. We only need this get function. But nevertheless, we kind of put here this request word and then the get word and so on. What if we just import all the functions that are available in the request? And this is also possible. You can say from requests import star, right? That means that you import all the functions that you can see here, right? All of them, to your namespace. And then you can execute this code and it's going to work and going to return you the same result. Here you see that we're just using this get function directly without putting this request in front of it, because we just imported this get. But this is really unrecommended way of doing things. One of the reasons is your namespace is now cluttered with a lot of functions that you're not going to use, right? So that's maybe just from an aesthetic point of view, not very nice. But the most important thing is that when you write in a long code, you don't know where this thing gets from, where you get this thing from. Is it defined in your code? Is it important from your model? Is it important from some other model? It will be pretty hard to understand where these functions actually originate, right? So that's why this thing is really not recommended. What is better way to deal with it is that, say, from requests, import get. In this case, you will import only one function. Yeah, let's restart the kernel. So we restart all our environment, and this is what you can do if you want to clean your environment. You can say whos again. It's empty, and then you say from request import get. What will be in our environment? Only this get function now. And then you can use it again directly without saying requests, and you get the same result. Another way that you will see very often in this course is saying import request as rq, import request as some alias. Why is it so? Because people are lazy. They don't want to type requests all the time. They just want to type something small, and this is how they shorten it. And this will result in this kind of code. You just can say rq.get, and this is in principle the best way to import your models, because now you know that okay, it's coming from something that called rq. In the beginning of your script, you will see that this rq is actually comes from the request model, and then you will know where this thing actually comes from, where this get function comes from. But again, if you're looking at the Python codes as a newcomer, it's going to be confusing in the beginning, but I hope that this will help you to understand the main ways how you import things. Okay, there is a question: can we start a loop in one cell Jupyter and edit it on another? I'm not really sure what you mean here, but well, not really sure. So if you start a loop, if you execute some codes, right? So there is this code. You hit the execution button, it will just do some work. You can like sleep. I'm not sure if I can. Yeah, there is no sleep here. Okay. You can edit this code during the execution. It's not a problem. You can see, okay, there is something going on, but I already know that this result is not what I'm will be happy about, but I know that I would like it to finish and see what if I truly right or no. So you can edit it during the execution. I mean, you can try it, right? So maybe I didn't understand the question correctly. Okay. Are there any questions to this one? Oh, how to save a written code in Py similar in Matplotlib? like m. Well, I mean, there are many ways, depends on what you want to do. If you want to save a little part of the code, like this only some cell, you can do it with this write file hello.py. If you want to save the whole Jupyter notebook in the Python as a Python code, you can in Jupyter notebook go to File, Download As, and there are several ways how you can transform a Jupyter notebook, including PDF. But you have to have LaTeX installed for this. And one of the ways is python.py. Let's see how it looks like. Okay, just have to move these things. Let's see how if it's gonna open. Yeah, it's opened it. So this is your Python, the Python code that is actually generated from the Jupyter notebook. So you can edit it afterwards. But to be honest with you, a lot of people ask it in the beginning, and almost when you start to work with Jupyter notebooks, you almost never do it. Like it's very rare when you want to save your Jupyter notebook in the python.py file. Usually you just create, if you really want to do this, you just create a new py file and just copy paste the parts of the code that you're happy with. What's the shortcut for making a new cell? Okay, that's important. First of all, if you can go to help and see what the keyboard shortcuts. Yeah, so here all the shortcuts that are available for you, and there are plenty of them. There are two modes in Jupyter notebooks. One of them is this: when the cell is green, then you can edit something, right? And another one, if when the cell is blue, when you press escape, the cell becomes blue, and this means, I think it's operation mode or something. So you can now navigate between the cells, right? If you put the cursor inside the cell, then you can navigate only inside the cell. Well, I mean, okay, you can switch between the borders of the cells, but then you will be in this edit mode. So in order to create a new cell, you have to be in this another mode, not the edit mode, but another mode. What is the name of it? A command mode, yeah, and the command mode. So your cell should be blue. Again, you just can press escape a couple of times. And if you want to generate the cell below, it's B. If you want to generate the cell above, it's cell A. If you don't want to do a shortcut, you can just always say cell. I think it's edit, right? No, you can just press this this plus button, and that will generate your new cell. Yeah, hope it's answered the question. If there are no further questions, let's move on, because as usual, it's already 1 hour. Okay, we're gonna do it even faster now. Now let's go for some very basic Python modules that you need to know about. And the first one is Numpy arrays. Numpy arrays are usually imported like import numpy as in p. So this is again about importing functions. And the Matplotlib inline, this is just a command that allows you to work with graphics in Jupyter notebooks. That the Jupyter notebook, the graphic that produced by your code will be inside of the Jupyter notebook. And let me just again remove all this, clear the cell output. Okay, Numpy arrays, as I told you before, the most important thing is that it's provide the n-dimensional array object, right? So lists that we talked about before are not actually going to help you too much with your scientific applications if they are involve more than, I don't know, 100 numbers. You need something that is more powerful, something that is similar to your MATLAB functionality, right? And for this, in Python, we have Numpy arrays. Let's just, for the sake of it, load some data into the Numpy array, and we load this data from the text file using the function load.txt. And this is our data, right? Some numbers. We can look at the shape of it. So it's an array, right? A NumPy array. The shape of it is 4,500 something by 4. So we are row first language in Python. So first number of rows, then number of columns. So it's another thing to complain about if you're coming from MATLAB. So in MATLAB is different. Here is the simple anatomy of the array. Again, the axis 0, again we're starting with 0, is rows, axis 1 is columns, and then the third axis, which is axis equals 2, is actually can be your depth, for example. The size of it is just a multiple of all the axes. It's not maybe that interesting. The type of this variable is now NumPy and dimensional array. So it's not list, it's not dictionary or anything like that. So it's a special type that you generate by, in this case, by open it with NumPy arrays, but you can just also generate it like by hand inside Python. But it has to be NumPy array. Each NumPy array has something that's called dtype or data type, and in this case is float64. The reason is that I think MATLAB has similar thing, is that it's much easier for compiler or like for NumPy, let's say, to operate with this array if it knows exactly that what kind of data type it's working with. Then it can do operations in a much more efficient way. Since we have float64, we cannot really put the string into this array. There will be an error. Slicing works also similarly to Matplotlib or MATLAB. So you can say from 0 to 5, that's mean rows, 5 rows, first 5 rows, and all the columns. Here we go, 5 rows, all the columns. You can also do from -5 rows to -1 row. So it will be only 4 columns here in this case, and all the columns. So if we go until the very end, then we have another extra column right here. So you can, like, I mean, it's very convenient also if you only want to work with the tail of your array. And one can very simply look at the data using Matplotlib, and we'll talk about Matplotlib in the next section. But you just import the Matplotlib in this strange way again. You just have to remember that that's a standard how you import Matplotlib, and the reason is that Matplotlib has several submodules, and one of them is PyLab, is the most important for the plotting. That's why we import it like this. Then you can say plt, so this thing that we just imported, plot, access the plot function from it, and provide the temperature, all the rows from the third column, and the third column will be 0, 1, 2, 3, right? So this one. You can have a look at this. Yeah, here we go. There's a question from Rebecca. Do you have to import those modules every time you open and use a new Jupyter notebook? Yes, you have to. Yeah, usually you import them in the beginning. There is a way to set up your environment in a way that this module is important every time you start a new notebook without like explicitly mention them, right? So there is a setting inside the Jupyter that you can say every time you create a notebook, import this. You can do it this way. I prefer that I know explicitly what kind of things are actually imported in my Jupyter notebook at the moment. So that's why I prefer to do it explicitly. Okay, next thing, index slicing. In general, it is similar to MATLAB. Yeah, first 12 elements, second column would be months, will be selected like this, right? So first 12 elements, first 12 months from the second column. And the first row, for example, will be selected like this. Here's the first row. But again, indexing starts with 0. Indexing starts with 0. It's very important to remember. Source of many errors in the beginning. Yeah, unfortunately. There are some exercises provided, but of course we don't have time for exercises. You can do them by yourself. So you can just try very simple things if you wish to. We can create a mask selecting all rows where values in the third row equals to 10. So now it's a little bit more complicated. I'm not really sure if I want to go into the details of that, because it's really a little bit more advanced than the usual NumPy arrays. Just saying that you can actually do some selections based on these indexes, right? So if you have this mask, the mask will be false, false, false. Well, let's have a look at the first 12 values of this mask. Some point will be true, and this true will be on the 10th, of course, on the month number 10th. And then you can substitute this mask, not the substitute, but like put this masked values, this Boolean array into the as a selection as the indexes, let's say for your temperature array, and it will select only the rows that are actually from the month number 10. Again, I don't think that we have time to cover this in detail, but the examples are here. You can have a look at them. So there can be some pretty complicated masks saying that everything that more than larger or equals to 10 or smaller than equals to 12 have to be selected. So this way you select your, I don't know, seasons or specific months, for example. Some basic operations on the NumPy arrays. This one, just create the new NumPy array. Again, just 12 numbers basically, but wrap it up in this NumPy array. So it's not a list. Again, it's a completely different thing, and which called NumPy array. You can add the numbers to it. So 1 plus 10, 2 plus 10. You can multiply the numbers, and you can multiply array by array. So by default, it's just doing array element-wise operations. It's not. I'm not sure if in Matlab it was changed, but yeah, in Python it's always like this. So it's element-wise by default. There are some funny examples that well, it's not funny. The question that I do ask the students, what's wrong with this figure, but I can tell you straight away that if we're talking about temperature, it cannot be really from minus 100 to 100. And the reason is that in this temperature data set, the temperature is in these strange numbers. It's not really kelvins, right? So it's something different. The reason why we have to process this data afterwards is that it's easier to store integers. They occupy less space. That's why you have to basically divide these things by 10 in order to get proper temperature down to the well, first decimal point after the comma. And yeah, this will be your temperature now. And that's pretty easy to do. You just divide it like inside. But I think again in Matlab is similar. Exercise, you can do it by yourself. Basic statistics. Again, here I just generate some temperature values. I use all the temperature values that I took from this file. This file is actually, I think it's the temperature in Hamburg for some temperature record from Hamburg. You can very easily do some very basic statistics. So each of the, let me show it to you. Each NumPy array has a lot of methods to it, right? So you can explore them. I mean, ton of the methods. So a lot of things that you can do with it. I don't know, transpose, for example, right? Which does make sense for one-dimensional array, but still. You can look at the mean. You can look at the max, mean, standard deviation, some things like that, and it's easily accessible to you. Just the dot away, let's say. You can also use the sum function from the NumPy array, but it's equivalent to using, in this case at least, it's equivalent to using this dot sum functionality. But you can wrap it in this way as well. There's a question for Maraike. Could you please again quickly explain how to navigate an array? Well, it's just the same. I don't know if you have the have some like MATLAB experience, but the arrays, here's an array, right? They are accessed by these square brackets, right? And each of the values in the array, it has an index. You can say from index 0 to index 5. Right? You get 5 values here. You can say from index 1 to 5, we will have only 4 of them. So this is basically this slicing thing. If you have not only one dimension but 2 dimensions in the array, you just use the comma and say that for the second dimension you have like that's for the second dimension you say we use from 0 to yeah. So and this will select some subset of your array. I know also from my experience with students that multidimensional arrays is a difficult topic if you don't have any experience with programming before. Understanding multidimensional array for people who have a lot of experience is pretty simple, but like because it's like in our blood, this is our bread and butter. We work with them every day. But for newcomers, it's not very easy to grasp it in the beginning. Again, two-dimensional arrays may be not that difficult, but three-dimensional or four-dimensional, five-dimensional arrays is already becoming complicated. So you would have to go through this topic by yourself. And I have some lectures somewhere, but don't want to waste time to look for it. You can drop me an email. I can just send you the link. I think I tried to explain it in one of the lectures in a reasonably good way. But again, it's not something that is easily accessible for just in a 2-minute explanation. Okay, so saving the data, you can also save the data that you have in this array. For example, we just opened this data from Hamburg. We want to convert them to usual normal temperatures, and we want to save it in a CSV file. It will be just one list of numbers. There is some formatting available associated to it, so we can just save it like this. That is the system function. You look at this. Just look at the first several lines of this file. This is how your file will look like. If you change the formatting a little bit, you can look at the file. So this is how it looks like, right? And so on and so forth. Like, I don't know, just for fun. I don't know, it's not going to work. But yeah. So you can play around, and this is important again for data handling, for when you convert from one thing to another. You can also save it as a binary with this command. Again, just showing you that it's pretty simple. I'm not going to go into details, and you will have at the end just the binary files with your numbers. Okay, you have a chance to ask the question now. Is question from Wilkin. Is there a non, not a number? Do the statistics work with that? Yes, there is. Sometimes before you had to apply some specific statistics, but specific functions instead of mean, there should be non-mean or something like that. But right now there is something that called masked arrays, and I'm going to cover it in the next when we will talk about Netcdf. A little bit I will touch it. So there are masked arrays, that have nonce in them, and you can have nonce in the Numpy arrays, but better to use masked arrays, so-called masked arrays that have by default all the operations on them actually disregard all the masked values. Yeah, we can have 2-minute rest. I actually would like to use it too. So let's reconvene in 5 minutes, okay? And in 14, 20, 25. Yeah, so it will be 7 minutes. Okay, so there is a question. I have a question. How can I clean all workspace, not only output? Depends on what exactly you mean, but if you want to restart your, let's say, workspace, you can say kernel restart. There are several options: restart, restart and clean output, restart and run all, and so on. So basically, restart will just clean everything and we'll start a new session, let's say. Hope it's answering. Yeah, I'm not starting. I'm just answering the question. Yeah, you still have time. I just decide to answer this small question very quickly. Yeah, sorry about that. Didn't thought about it. Yeah, I can repeat it afterwards. Okay, let's continue. One thing, I just repeat the answer to the question: how I can clean all the workspace, not only the output. That can be done by just restarting the kernel. I don't want to restart this one, but yeah, that's another way to restart the kernel, actually, just to use this button. But there is this you can select it from this kernel drop down menu. You can say interrupt, restart, and clean output. So basically, restart will clean your workspace, and that's gonna make it. Another thing that I just sent into the chat, there is my attempt to explain what the n-dimensional arrays are for people who doesn't work with them before. And there is this example on slicing, why the slicing works as it works in Python. And then there is attempt to visualize the n-dimensional arrays and some exercises, which not really sure what that's mean, but yeah, I have to maybe work on this a little bit more. But yeah, so you can have a look and see if it will be helpful for you. We are continue with now with the next section, and it's work with different data formats. And that's, again, I think it's pretty important for most of us, is we would like to basically, in many cases, just open the data, do something with it, and maybe save them afterwards. And the main data formats that I work with is binary and Netcdf. I also put here some example of the working with .mat format, which is the output of MATLAB. But, well, I think binary and Netcdf covers like 90% of the cases, and ASCII, of course, 90% of the cases with in geoscientific world. Maybe Excel as well, but yeah, this is also possible to work with, but I'm not going to cover it here. Okay, so first thing first, we just import Matplotlib to make some plots. I think, yeah, plotting is coming up next. And we import the Numpy. For binary data, I just downloaded from here. So you have to uncomment this line and just wget, and download it some other way, because wget doesn't work on Windows. So you have to just maybe put this line into your browser and just download it in the place where you can access it, and particularly to this Python for Geoscientists folder. And then you can say, you can use again Numpy in order to open the binary data. What's happened here? We use the function from file. We provide the path name to the file. So if it's stored in your case in some different place, you just change the pathway here. And we provide the data type. That's the most confusing way. Well, I mean, most difficult way in some of the cases, because this is something that you have to know from the documentation. You have to know what kind of data type your data are in. Although try and error usually also work. If your data look like sea ice after you plot them, that's probably your data type was the right one. In this case, is Unit 8 data type. Here is the list of all the data types that are available for NumPy. It covers all the basic things. Floats, doubles, long doubles, and so on and so forth. I think you will find your data type anyway if you need something exotic. And I know from the file format description, which is located here, that the first 300 bytes are actually a description. I don't want to look at them. I kind of infer everything I need from the file name, let's say. So I just don't want to have them. So we can actually look how this data looks like. So there are some numbers, blah, blah, blah. But I don't want to have them because first 300 records are not not the data themselves, is just the metadata. So what I'm saying is just return everything after first 300 records, right? So 300 is the first index, and then go until the end with this column, right? And then my eyes will look like this. Yeah. Well, I mean, there is a lot of zero values for this eyes. But then again, this thing is one-dimensional array. You have to reshape it somehow. And again, from the documentation, you know the dimensions of your array. The simplest thing to do here is just to use this reshape, which is something that is now a method of our data, right? Again, this is my data, and I have a lot of methods because this data is NumPy array right now. And we apply this function here, and our eyes now is, well, let me just clean everything, otherwise it's not fun. All good, clear. Yeah, so this is our eyes. Now it's two-dimensional array, and the shape of this two-dimensional array is the shape that we, of course, you have to your shape have to be consistent with the numbers that you get for your one-dimensional array. Simple visualization with Matplotlib. The simplest thing that you can do is just use imshow. Imshow is similar to what you have in the in MATLAB. It's just showing your array, your two-dimensional array, like visualize your two-dimensional array, just numbers converted to to colors. I don't know how to explain it better. There is one additional thing that I use here. It's called plt.colorbar. Just put this color bar here. Again, Matplotlib was initially designed after some MATLAB functions, so a lot of things in Matplotlib will be familiar for people who use MATLAB. Well, this is sea ice, obviously. Well, not obviously, but believe me, it's sea ice. But it goes from 0 to 250, which is unusual. The reason is, again, the same. It's easier to distribute the integers, and in this case, unsigned integers. So the amount of data is, well, much smaller. And it was important when this data set was created because it was before the internet era. And yeah, transfer was expensive. So in order to convert to usual values, which is from 0 to 1, you have to divide it by 200. Easy thing, because you just can use this syntaxes to divide by 250. And this is now your values from 0 to 1. And now it comes to the masked arrays, because these areas are useless, right? So this is land, we don't want it. We want to exclude it from our analysis, for example, if we want to create a mean. And this thing in the middle is also, for those who knows about sea ice observations, this is satellite sea ice observations, and they know this hole in the center of the around the North Pole very well, because the satellites cannot reach this area, so that's why we don't have data here. And from the description of the data, we know that these values are actually has some, well, I mean, this hole in the middle, and the land has two different numbers, but they all more than 1. So everything that is larger than 1 is not data. So we can actually have a look. Well, I mean, it's not very different, so I'm not really sure what I try to say here. But what we want to do is we would like to create something that's called ice masked. And ice masked is the masked array that's saying that, well, basically this set of masked arrays is, yeah, a lot of functionality related to masked arrays can be accessed for this. And there is this link about masked arrays with Numpy. And what you can do, you can say masked greater than 1, right? You can have here like masked all, mask equal, greater than equal, and so on. So there are different functions for making new masks. But in this case, we say mask greater, take all the data from here, compare them with 1, and everything that is larger than 1 will be masked. Then we plot it with imshow and add the color bar. There is one additional thing here. Since some versions of MATLAB, they decided the better thing would be to use some fancy interpolation for, not fancy, but some interpolation for imshow. And this is not what I want usually. I want just pure numbers, so that there is no interpolation. If you use it by default, it will look like this. It's not what I really want. Maybe better to look at, especially for bigger data. But if you, well, I mean, it just loses all the details. So you can just say interpolation known, and you will have this. You will have this this figure, right? So automatically Matplotlib, again about Matplotlib, it's the next section will be about Matplotlib. It automatically understands that, okay, it's a masked array. I'm gonna plot the mask in well, will be the white spaces everywhere where the values are masked. And you can save the binary file that you actually created with this ice, yeah, this one, right, that we used before, not the masked one. Masked one not gonna work that easily, but the original one you can actually save. And again, this ice array has one of the options to file, right, or 2 bytes, or I mean, there are many options that you can apply to this NumPy arrays, and one of them is to file. So you save your data to file, you have to open so you cannot just provide the name of the file. You have to open the file identifier. Then, yeah, just make this, put this data into this file that is described by file identifier, and don't forget to close it. Question from Donna: is there any easy way to extract the metadata of the Netcdf? Yeah, it's just the next thing that we're gonna cover. Geographical coverage parameters. Not the next one, over the next one. So the next one will be mat files, and here I introduced the SciPy module. It's a general purpose scientific library. There are some functionality that is described here. A lot of things, well, almost everything that you can think of is already implemented somewhere in Python. Usually it's in SciPy or in some, some maybe other library. But there's a big chance that the analysis, especially mathematical analysis that you're searching for, is implemented in one of the Python packages. With SciPy, one of the things that they have is this SciPy IO. It allows you to work in particular with mat files. And here I just show you that it's possible, right? So you just import this load map. We're going to use some data from polar central hydrographic climatology saved in MATLAB format. So the procedure is also pretty straightforward. You just say like load map, and this is the name of your file. There is this all variables. Let's have a look what's inside there. Yeah, so this is something I call dictionary. We didn't cover dictionaries here, but I mean it's just a structure that contains some information that can be accessed by this interface, right? There are some keys in this dictionary, so that some parts of this kind of a data set you can think of, right? So there are some parts of it, and different parts of it can be accessed by just saying in square brackets, okay, return me this pytemp1, so this thing, right? And we can say this, and the temperature will look like this. And so this is something that you saved in your MATLAB file, and then you want to. So I think it's like if you save it in mat file, then it saves kind of the whole workspace or environment for you. Again, my last experience with MATLAB was a pretty long time ago. I don't remember. Yeah, but then you can kind of recover it or transfer this data to Python. Let's look at this. Yeah, if you want to delete something, so for example, you have some you're reading something in the cell, you can just press escape to get into this command mode and type letter D 2 times, and then your cell is deleted. So this is another tip for working with Jupyter notebooks. Okay, the shape of this file is 33 by 180 360, so it's obviously, well, not obviously, but I know that it's depth, latitudes, longitudes, and we can just look at the first depth level, like here, right? Again, this is the index of the depth, right? So this one, so 0th depths, and all the latitudes, all the longitudes. And we just also plot the color bar. And again, it's just easy as using imshow. Yeah, that was mat files. Again, most of it is just working with Numpy arrays at the end, right? So the only part of related to mat files is just that you can load them and you can extract the variables from them. Okay, very interesting thing is open Netcdf files. Netcdf files are so popular that there are many ways right now to open them with Python. One of the popular ones was also to use SciPy to open the Netcdf files. I really advise you not to do this. And if you have some scripts that do using SciPy Netcdf capabilities, just rewrite them with Python Netcdf. So this next thing that I recommend here, because this is kind of a standard if you want to do some kind of basic looking at the data. One of the reasons that SciPy doesn't support Netcdf4, and a lot of data, more and more data now distributed with Netcdf4. Later in the course, I hope we will have time to look at the X-array at least a little bit. This is more advanced, let's say, way to look at the Netcdf files that you don't, well, it's not as low level, let's say, as Netcdf4, but it's actually allows you to do much more and much more in much more easier way. Okay, but let's look at very basic operations of working with Netcdf files. Again, another weird import. In order to import the Netcdf capabilities from Netcdf4, you have to actually import the dataset from Netcdf, from the library Netcdf4, because Netcdf4 library contains some other functions as well, but the dataset will be something that will be most useful for us. There is a question from Lotana. So does the function shape gives the maximum value of data? No, the function shape gives you the shape of your n-dimensional array. So again, there should be some temp. Yeah, temp shape. This means it's not the maximum values. This means that you have a cube, right? Basically, so you have one. Yeah, you have depth, you have latitudes, and you have longitudes. And so there is a cube that you can describe by these numbers. You have 33 layers in this cube, and you have 180 latitudes and 380 longitudes. It's easy to think about it as a cube that describes the atmosphere or the ocean or the globe, right? So again, that's a question about multi-dimensional arrays. If you want to have some maximum values, there is the max function that works for all the data in this cube. Okay. Yeah. Okay. So we imported this dataset function. Let's open the data. Opening the data is as simple as just provide the name of the file or the path to the file. But what you get in return is not actually a real data, right? It's just a descriptor of your file. This is something that you can then extract data from. This is very convenient because you don't want to immediately open huge terabyte size data sets, right? So you want to first have some information about them. And this is what allows you to look at some information. Right? You can access some global, again, you have to know a little bit about Netcdf files in order to understand fully what is going on here. And for example, here I'm accessing the global attributes of the Netcdf files, like description and history. And you can see that they're actually here as well, right? So again, with this descriptor, you have a lot of different methods that you can work with. And I'm showing only the basic ones. Okay, the most important for us, of course, is just variables. What kind of variables you have in this Netcdf files. And by saying dot variables, you get the dictionary. Again, we don't cover the dictionaries here, but just basically the information about what kind of variables you have in there. The way how the data is represented is not very optimal, let's say, but this is the way it is. So we have latitudes, we have longitudes, we have time, and we have air somewhere here, right? And we have some attributes for each of these variables. Okay, let's look at the air variable. We can say variables and select the variable air from this list of the variables. If you want to have just a short version of the thing that you saw before, just can say keys, right? And this is the options that you have to select the variables, right? So you can select any of them, and we decide to select air. Again, if there is no data yet transferred to our operational memory, this is again just a descriptor. just says that, okay, I would like to work with this variable air. What do you want to do with it? Do you want me to look at some attributes, or you want me to actually access the data from this variable? So let's first look at some of the attributes of this data. So you can have look at the actual range, and this is here. I mean, basically, all this information is printed for you if you just execute the cell with the name of the variable. Long name, units, shape. Shape is something that is different. Again, this is similar to the data that we looked before. It's just a cube. But this cube is located in time. So this is surface temperature, right? 366 steps, time steps. So instead of the depth levels, we have time steps, and we have latitudes and longitudes. Right? So this is our shape. And finally, only in this stage, when we access our data like this, right, with the square brackets interface, we load some data into the memory, because before it was just pointers to the data. And in this case, you actually load the data, but you load only the first time step. That's also very important, because most of the time you don't want to have all 366 data, especially if the data are big, right? If you want to access only one time step, it's very easy to do. You just select the 0th index of this of this field, and then you can see that there is, okay, it's atmospheric temperature, so you see some continents also here. There is some exercise, and I will show you in the next kind of section how to plot things in a much better way. But this is how you access data. And here I demonstrate how easy it is to actually create Netcdf files, because for many people it's kind of pain in the back, and because a lot of us like Netcdf files and like the data to be transferred with Netcdf files, because the metadata can be saved there. And I just show here in these two examples that it's super easy to create the basic Netcdf file. You just say, okay, this is the name of my file and I want to write it. You create dimensions. Again, not going to go into the details of Netcdf files. For those who understand it, I think it would be clear. So you create 3 dimensions, because this is how many dimensions in your data are. Then you create the variable, and you say that it's called air, will be flow 32, and it will depend on these 3 dimensions. And then you put the data from our actual variable to this Netcdf variable, and then you close. And if you execute this, you will get, hopefully, here. Let's see, dump. You'll get this super simple Netcdf file, but it will be valid Netcdf file. Let's try to look at it with ANSI view. Yeah, it's actually working. So with ANSI view, and it was only 5 lines of code, but it's pretty simple one. More complicated one that follows a little bit more standards is shown here. I'm not going to go into too details, but you provide some coordinate variables and so on and so forth, some additional data, and this will look like this. So more a little bit more interesting, and then you also will understand it, and will understand latitudes and longitudes because they are properly defined. Yeah, and it's also, this is not 5 lines of code, but it's, well, not much more, right? And this can be done very easily. Okay, if there are questions about this section, or everybody is so exhausted already, so that there is no questions. So you still have chance to ask it. Okay, then let's move on to the next one. the graphs, the graphics, how we visualize our things, how we put our data to the plots and to the maps as well. As I said, Matplotlib is the basic visualization library for Python, and here I show just very super basic examples for Matplotlib, because there are tons of material about it in online. Just have to understand that if you want to plot something and use some very default library that a lot of people still use, then the Matplotlib is something that you have to look for. We do some imports, Matplotlib inline, saying that our data are going to be visualized in the Jupyter notebook. Importing Matplotlib, and you import it in this way, and import Numpy because we need to generate some data for it. Let's generate first some data, saying np linspace. Linspace functions actually creates 20 points in the range from 0 to 10. And then y, we just square the x. So this is our two variables that we would like to plot. And let's plot them with just plt.plot x, y. Here is your plot. You can style it with different, with a style that is similar to MATLAB. So this will be kind of familiar to those who use MATLAB. And you say here that the label will be x, the x label x, the y label y, and there is a title here. And you can also plot 3 different data sets together in one plot. So if you execute this plt.plot in one section, in one cell, then it's going to plot them together. If you do it in a separate way, then it will be 1, and then another 2, and another 1. Yeah? So that's very convenient when you have some different data sets. You just put them together on one graph. You can put them together on one graph. There is some exercise. There are alternatives. Matplotlib actually showing its age. People still develop it very actively, but you have different alternatives. One of them, like there are a ton of them actually. The most popular ones are Bokeh, Plotly, HoloViews. You can follow the links and look at this versions. Bokeh and Plotly and HoloViews, the 3 of them actually gives you much more interactive capabilities. You actually can have your plots interactive in Matplotlib as well. But those are the natively interactive plots. There's a question: are 3 graphics handles? The graphics handle similar to MATLAB that can be accessed via get set. Well, there are, yeah. It's one of the problems actually with Matplotlib that I have, is that there are 3 or 4 ways to do the same thing with one graph. With Matplotlib, and yes, you can do this get set things as well. So this more I think a more object-oriented way. You can do it with this PLT interface and so on and so forth. I don't really like it, but because I mean, really, you can find 3 different solutions for one problem online. And that's why Matplotlib is my beloved tool, let's say. But this is, if you want to write some generic code that most of the people will be able to understand, then Matplotlib is still the standard. How different from ggplot? Matplotlib PyPlot is better. I don't know. The ggplot is, I think it's an R tool. There is some ggplot port to Python. So this one, yeah. I'm not really sure if it's a. Well, I mean, they're sure this one is about. No, this is the Python. Yeah, this is a Python plot of the R ggplot. I think it's also called ggplot. But well, I mean, that's a matter of taste, and for different applications, different packages are better. right? So if you want to do something interactively, then Bouquet is certainly your choice. If you want to be similar to R, I mean, ggplot is also should be fine. There are a couple of more examples here. I don't want to really spend too much time on them. There's this funny styling that you can also apply to your graphs. Here, I think everything is more or less self-explanatory. What's going on here? So you're setting some properties for this graph. Important thing is written here that if you want to do some plot with Matplotlib, the easiest way just to go to this gallery, Matplotlib gallery, and it's not really what I wanted to show. Where is it? Here, Matplotlib example gallery. So you just go here and select the plot that is as close as possible to the plot that you want to generate. And then you go here, click on it, and you will see the code that actually generate this plot with some explanations, usually a lot of explanations. And that's the best way to actually start with Matplotlib. So that's, I think, that's it, what I wanted to say about Matplotlib. You have to look at it by yourself, and there's a lot of resources on how to use it online. Okay. What is better, Matplotlib or Seaborn? Well, Seaborn is actually based on Matplotlib. So Seaborn doesn't really plot. For those who doesn't know what is Seaborn, Seaborn is a nice library that do statistics basically, and actually do a lot of very nice plotting. Well, it's a wrapper around Matplotlib that do very nice plotting, but plotting itself is actually done by Matplotlib. Seaborn just style it in a very nice way. And actually, a lot of things that now in Matplotlib comes from Seaborn, because Matplotlib people realized that they plots were looking so ugly that nobody was able to look at them anymore. So now the default plots are actually pretty nice with Matplotlib, and this is the influence from Seaborn. Okay. Okay. So next thing is going to be about maps. So my promise of 2 hours looks like it was a lie. I'm not gonna make it in 2 hours. 2.5 hours also probably will be pretty tough. But like, it's not gonna be more than 1 more hour, because we just have a reservation of this room for 3 hours only. One of the most important things, of course, for us is to put the data on the map. And as my alma mater says, everything starts with the map and everything ends with the map. And this is what functionality that is super necessary for us, of course. For a long time, the standard thing for plotting maps in Python was something I call base map, and you will find a lot of resources related to base map online and a lot of examples. Unfortunately, if you're starting learning Python and using Python right now, base map is not a good investment, because it's not supported anymore, and it's not going to be working with it's not working with version of Python after 3.7, I think. And 3.9, I think, is the current standard, the latest version of stable version of Python 3. So it's not going to be supported anymore, although it's pretty nice. It was pretty nice, and it still has sometimes some of the capabilities still not matched in the other package that we're going to talk about. But probably you have to forget about the base map. You have to know that it exists, but if you write in a new code, don't use base map. And the next thing that comes instead of base map, called cartopy. And with cartopy, again, let's clear the output. I'll just show you several examples of how to use it. And my basic idea is just to show you that it's easy. It doesn't require a lot of lines of code, and it's more or less yeah, it's more or less reliable, I would say. Okay, there is a website here. We have to do this imports. The Cartopy related imports is this Cartopy CRC. And the Cartopy feature that we have to import, and I will show you how to work with them just in a second. So the very basic thing that you can do with Cartopy is just to create a figure, and then you create a so-called axis that actually understands the projections. Again, I don't have time to go into very much details, just to show how things work and just explain you very, very basic things that you can figure out details by yourself afterwards. So this axis actually understands the Mercator project, and there are projection, and they are in Mercator projection. So the next thing that we can add coastlines, and it will look like this, right? So okay, that's already looks like a map. Then what we want to do, we would like not to look at the global map, we would like to set some extent. So this is another line that we add from 100 to 20 from left to right, and from 20 to 60 from bottom to top. Yeah, so here we're looking at some North Atlantic Ocean. There is a lot of projections available for you in Cartopy, and much more than it was like a year ago. They added a ton. So you can select from different kind of projections the one that, oh my god, the one that you like. But well, I usually work with only 2 or 3 of them. So the fancy projections not very useful, I think, in the scientific work most of the time. But the one that is very important for us is North Polar stereo projection and South Polar stereo projections. So North Polar stereo projection can be kind of activated like this. So you must provide, especially if you're plotting the data, you must provide this extent. And this is sometimes the source of confusion is when people try to plot something on North Polar stereographic projection. You have to provide this extent, unfortunately. And this thing is also pretty important. It's not very obvious from the documentation as well. Extent is provided in the plot-Curie kind of coordinates. So it just gives this set extent an idea that you don't want to set extent in some in kilometers, let's say. You want to set extent in the degrees. In the geographical coordinates, and this is basically what is indicated here, right? And then we can look at the South Polar stereo, and it's not like I'm typing so fast, but if you start to type something, if you press tab, then you can autocomplete the things, right? So that's another tip about using Jupyter notebooks. South Polar stereo, so we want to go from -90 to like 50, something like that. To -50, of course. Yeah, here's your South Polar stereo projection. Let's get back to the usual one. One thing that I changed here is this resolution. So I just add another, like more a better resolution to the coastline. There is even higher resolution if you need it, if you really zoom in. Another thing here is adding a feature that basically filling in the continents. For ocean scientists is important. Atmospheric scientists find it weird, but but we actually need it in a lot of cases. We want to fill the continents with some color, and this is what happened here. You can also define the course here, and in principle, you don't even need the coastlines in this case, right? So you can just do it like this, but you can keep the coastlines if you wish. Okay, we prepare our map. Let's put some data on it. To get the data, I use this the same file that I used before. We just extract the first time step from this AR variable. It's I just reminded that it's sea surface temperature, not sea. Yeah, it's atmospheric temperature 2 meters. We also get the latitude and longitude variables. And just to give you an idea how these things look like, so this is latitude, is just one-dimensional array of latitudes. Right? What is important here is that I use this square bracket thing, right? That's mean that I'm not I don't want just to have to get information about this air variable, but I want actually the data. And the same thing is true for latitude. So I'm just saying by putting this here, I'm just saying give me the data, not just the metadata about the latitude. And let's plot it. So this is our first map data, put it on the map. I just use usual contour F function. Is again is the method that becomes available for you when you create this axis with this projection Mercator. It's contour F. It's field contours. You provide longitudes. You provide latitudes. You provide your data, two-dimensional, of course, and you do you're saying again this transform plat Curie. What does it mean? That means that my data are in geographical coordinates. That's it. So that's the only thing that you have to remember about this. Your projection and setting for your maps are actually defined here. So this is projection of your map. This is the extent of your map. But this is just saying that the data in geographical coordinate, just be clever and transform them into Mercator projection internally somehow. Okay, you see here we have a little problem. This is called a cyclic point problem because our data doesn't really go like end to end when you wrap them up around the globe. This problem is very easily solved by another function that you can import from CartoPyUtil called addCyclicPoint. And what it does, it just add another sort of layer to your data and another column of data, let's say, and another value to your longitude. And you get back this rcyc and longcyc, the fixed data and fixed longitudes. For the global data, it's usually, well, I mean, in many cases you have to do it. There is a question from Yana. What is the difference between RNC? Wow, I don't like. There is the code that let me just put it here. That you provide. Let me see if there is a difference between these things. So this is it's not NC, it's FL, right? Variables. Okay, that will be just the data, right? And again, it's going to be a masked array. That's also interesting note. So if you have only ocean data, it will be masked. And this thing, I assume what you mean is just this. I just wonder what will happen here. It actually gives you some again some two-dimensional array. Looks like there is no well, I mean, what happens here? You apply this this column thing several times to your variable, right? In this case, you just select by one go, just very easily by one go, select 0th, okay, first or 0th value from your three-dimensional array, right? So the first time step of your two-dimensional data. In this case, what you did, you just do it 3 times, but the result is the same. First, you select. Oh yeah. What happens here is well, I mean, first you select here the 0th time step, and then you say everything everything. Select me everything, and again everything. So it basically doesn't do anything. What may be important to see is that there is no difference between this and this code. The reason is that by default, this 0 will be applied to your first dimension, or 0th dimension, right? So you can, in principle, write it in this way. But I prefer, and most of the people also advise to actually explicitly select or explicitly indicate what you select from your dimensions, because your air is actually three-dimensional array, and here you're saying, okay, 0th from 0th dimension, 0 value from 0th dimension, everything from the second dimension, everything from the third dimension. So this two are equivalent, and your version is also equivalent, but this is just better practice. Okay, so we just come back to the cyclic point. Let's see the results. If it works or not. Yeah, it did. So you see this line actually disappeared, and we here use this lone cyc instead of lone. Latitudes is not changed, so we use it again just latitudes, and air cyclic is our new data set that just have an extra well, an extra column in it. What is also important to note that it doesn't really matter if you provide one-dimensional arrays or two-dimensional arrays. So if you create two-dimensional arrays from your longitudes and latitudes, or you have, see, this is a two-dimensional array, then you also can provide it just directly, so the cartopy will take care of it for you. It's not a problem. What else I wanted to show? Okay, so there is a little bit more control over the display of your data. And again, we can forget now about this part. We only work with these contour options, and these contour options are Matplotlib options. That's also kind of important to understand that cartopy only works with the projections and transformations of your data for before plotting, but the plotting itself is actually done in the most cases using the standard interface of Matplotlib. Okay, so here we just define what we added here. We just define this the levels here, and it's in Kelvin, so that's why we we have a lot of 51 levels, and it looks like this. You see that we have a blank spot here. Unfortunately, we have, or fortunately, we have some temperatures below 275 kelvins. What can we do? We can expand, of course, our space. Well, we can expand the range that we working with, or we can just say here that we work with. We just extend set extend to both. That means that everything that is below 275 will be just blue. Everything that is above 300 will be just yellowish. And there are a couple of other like beautifications here. I added the color bar. I added like increase the number, the size of tick parameters, and set the label. So this is yeah, just some beautifications. Here's an example of how you put the grid lines again. So just here and here. Right now, one thing to notice that the green lines only in the standard version only work for Platkerry and Mercator. Not the green lines, but this labels for grid lines. But there is in the next version this will be available for all the projections, so hopefully for most of the projections. So let me see. Yeah, so all the projection will be able to give you this kind of maps. Right now, it's only available for Mercator and Platkerry. Okay, there is a question. You provide colors as names. Light face color for the land masses. Is RGB working too, like 05, 05, 05 in the 0 for 1 to 1 range, or do colors range from 0 to 255? I think you can provide in both standards. This RGB colors, you can provide also hashes from this HTML colors, but again, you have to try. Usually, colors can be provided as RGB, as named colors from HTML. This colors, HTML colors that start with hash. I don't really know how they're called. So, and whatever you can imagine, you can actually use. So that's usually not a problem. Sure. Okay. Next thing. Okay. So it's not that bad. We have only two big important things to cover. Okay, question from all. Does the machinery accept data long lat vectors instead of 2D? Yes, long lat vectors. It's the version that we, yeah, so first 2 or 3 figures, we actually provide long lat as vectors, but one-dimensional vectors. You don't have to provide 2D. Yeah, so it's going to work with 1D as well, if your data are regular. I've heard you say it, but I couldn't believe. Thanks. Yeah, it's such a complicated functionality, but yeah, it's amazing that that somebody implemented it. Time series pandas. Okay, we have only 2 things to cover, 2 important things to cover, and I hope to do it again in a more or less quick way. Time series analysis of pandas, and I think that's for a lot of people actually that would be maybe the most important most important part, because this package actually saved a lot of time for myself, and a really big fan of it, because it allows you to work with time series in a very efficient and very nice interactive way. What it is like, I mean, it's written here. There are a couple of links to the videos from the creator of the package, Wes McKinney. This is basically can be seen as the Excel on steroids again, or some database interface to Python. But Excel is a nice, I think, is a nice Excel analogous is a nice description of it. People from R actually will recognize a lot of things from R, because it's the data frames are based on the R data frames. At least the initial idea of it was taken from R. Okay, we import pandas as PD here, and then I also put here a couple of beautifying options that our data look better. We're gonna work with some data from daily temperature, daily temperatures, and this file is showing the maximum temperatures in Delhi from 1944. First thing that, and this is Pandas is very powerful in this respect, it allows you to read the text data. And there is a lot of read functions from in Pandas, including read from Excel. So you can load the Excel data, you can load some database data, JSON, and so on and so forth. But this read CSV basically works with the text data and have a lot of options for you to actually like read the data to Python. We could have used this Numpy load text, of course, but here there is already some interesting advantage of pandas. You remember that if you look at this data, here's a year, month, and day, obviously, right? If we load txt with NumPy, there will be just just 4 columns with these values. What we have here, we just set to pandas that I would like to parse the date, and the dates are actually located in zeros, first and second columns. And what you have in return is your dates are parsed, right? So Pandas understands now that this is not just numbers; it's the dates. And you can see already that it reminds you of the Excel spreadsheet columns, right? Then you can, of course, change the names of these columns because 012 is not really descriptive. And set the date column to be your index, right? So now we have the date column and the temp column. So we get rid of this index column, and now the dates becomes black. That means that your dates are your index. I'm not going to go into very much detail about that, but that means that you can actually kind of work with these dates as dates. Pandas will understand that this is not just numbers, it's dates. So what you can do immediately is to plot your data. Your data have dates, your data have values. It can be plotted. The Pandas understands that it's the dates, and it just puts this years here, right? So it's very kind of convenient way of looking at the data, that you already kind of associated with them with dates, not just with some strange numbers. The cool thing is that you can select the dates. So this is the year 1980 to 1990. You just select it by providing these two numbers and separate it with column, and you can plot them immediately. This is what your plot will look like. You can select some month, start as a starting point and the ending point, and these dates will be more granular, let's say, or you can select some specific month or specific date, sorry, and you will get some temperature this date in return. If you want to access the data by index, saying that it's 120th record in my data, then you can do it with this ilog interface, just location, index location of this data. And what will happen if you choose only 1 month without this range? It will just show you 1 month. I think already this functionality saves you a lot of time, because I remember how it was before. Pandas, you have to know which index is which date, and that was pretty hard to work with time series data with Python. I'm not going to go through this. Okay, there was one column of our data. Let's add another column to this data. We looked at maximum temperatures in Delhi. Now let's look at minimum temperatures in Delhi, and we just create this temperature mean variable. Well, I mean, but without like big explanations, right? So we just apply everything that we apply to a temperature maximum, but in one cell. So you can look at the data immediately. You can describe this data. This is for minimum temperature. This is for maximum temperature. By applying this describe, you can see very basic statistics of this data. And then we would like to actually join this data. To join them together, we create an empty data that have all the dates from 1944 to 2015. So this is our dates. We just can create the date range. There's a special function in Pandas to do this. And we can create an empty data frame. So this data structure is called data frames. Now it's empty. There is nothing in here. And now we want to fill it with our minimum index T min and T max. And you can simply do it by just assigning these variables to this to the values into this data frame. And our TMP now looks like this. We have the column with T min and column with T max. Some of them have values, and some of the like in both of the at some dates both of them have values, and some dates only one of them have values. You can again plot these things straight away. together in one graph. Very simple interface to plot things, right? You can plot them one by one. You can just say, okay, I want to plot only mean column, and it can be done like this. Or if your name of your column is actually a valid Python name, for example, it doesn't start with number, then you can plot it even like this. Like this, it can be more convenient for you sometimes. You can create new column in the data frame that actually is a combination of your two previous columns, right? So in this case, I just would like to create a new column that called tmean, that called mean, that actually consists of the mean of these two columns. Here is my new column. If there is a none in one of this, there will be none in the mean. You can avoid it, but like by default, if there is even one none, there will be none. You can create another column that actually subtract one from another. Again, if there is a none, there will be none. I'm not going to go to this exercise, but I'm going to delete this diff and none and mean values. Next thing is statistics about your data. Mean statistics. This is the mean. In this case, the nonce are not included. Just look at the, of course, on the valid values. Maximum, minimum. So minimum temperature in Delhi was 30. Maximum temperature in Delhi was 36, and the minimum temperature was 0. There was a time when in Delhi was 0 degrees Celsius. You can do it this statistic row-wise, so it tries to calculate them row-wise. You can again just describe this variable, so we'll just provide you some very basic statistics, and the most beloved thing of all scientists is the correlation coefficient. Can be done just again with one line of code, and you can see that minimum and maximum temperatures are correlated with a coefficient of 0.8, which is pretty high. What else you can do? You can do resampling. So you have daily data, you want to get the monthly data out of it. How you do it? There is a resample attribute, or basically function, that is available for you. There are some, information about how to use it, and this is actually pretty powerful. So there is a lot of things that you can do with it. Again, very basic thing. You say, okay, I would like to create a new variable that will be created from my old TMP variable that have my two columns. I would like to resample the data with monthly values, and for each of these monthly chunks, I would like to apply mean function, right? In principle, first thing to note is that pandas understand what the months mean. It doesn't use like 30 days or anything like that. It understands that you have dates, and understands that some months have 30 values, and some of them have 31, some of them even less. It will select these chunks according to to the dates, to the real dates. Then with these chunks, you can do whatever you want. So basically, you can define your own function that do whatever is needed to you to this monthly data. The important thing is that you, as an input, you have this the chunk of the data that represents the month, and as an output, you have to have only one value. So some aggregation have to happen, after which you have only one value. And this is like the simplest thing is the mean, right? And here I plot only everything that is starting in the year 2000. You can do the 3 month resampling. This is doing it every 3 months. Of course, it doesn't make too much sense, because every 3 months we will start in January, February, and then March will be our 3rd month. So it's not really a seasonal thing, and how to do seasonal thing I will show next. You can specify several functions in at once. So this apply thing is actually the sort of a right way to do this resampling, because applying, we just apply some numpy function here. Mean is just a shortcut for this well, but for this syntaxes, but of course for mean we would have to put mean here. You can apply several functions as well if you wish. So maximum, minimum, and you can apply mean and so on. So you immediately will see the result here. You can do seasonal means, of course. For seasonal means, you have to apply as your as your period. You have to apply something that is called Q November, and that means that it's quarters that actually with ending in November. In this case, you can apply your you can have your winter, summer, spring, and autumn things, and you can plot them. The reason why it's in quarters is because Pandas initially is tuned to do financial analysis, and Wes is actually a financial expert, so that's why it was it full of this financial terminology. And what I try to do here is I plot the first quarter, and the first quarter in my case will be winter. So I'm just plotting the winter means. Of course, if there are nonce, there will be no values. So you can deal with it somehow, and we will deal with it a little bit in the next section as well. Multi-year monthly mean with group by. So, okay, you plot some monthly means. You would like to see how your seasonal cycle look like. You can also do this, and for this, there is a very powerful instrument that's called group by. First thing that we do for this temperature TMP variable, we will create a new index, a new column that will take the values from our index. And what I mean by that, so let's have a look at the temperature values. Okay, we have this index here that actually represent our dates. We can look at it. Here's our index, and there are several things that you can do with this index. And one of them, you can extract all the months from this index. So it says that for record 1, the month is 1. For record 2, the month is 1. For record 3, the month is 1, and so on and so forth. And this information can be put in the third column. You see, here's our months. And then you can use group by to say, first select, and this is again, thing that I was talking to you, telling you in the beginning, this chains that sometimes a little bit harder to decipher, but that is very convenient to work with when you do the analysis. You say here that I would like to select only years from 1950 to 2013, group by all the data by month, so all the data from January will be located in one bucket. All the data from February will be located in another bucket, and then I want to do something with these buckets, and I want to aggregate. And how do I want to aggregate? I would like to create a mean out of it. You can do standard deviation, you can do whatever you want, but in this case, I would like to make a mean, and then I plot the data. So this is the example of how you do the seasonal cycle in one line of code that is actually extended, well, okay, 2 lines of code because you have to put this index here, and then another line of code to actually visualize it, and you do it for two variables. That's very convenient for interactive analysis. This is a bonus example of the box plot that you can do, and this is this is the way how you can do this box plot. Again, just by executing one command, and I do the separate box plot for Tmax and Tmin here. The last thing is to interpolate. I just wanted to show that it's also possible, because our data, as you can see here, they're actually full of gaps, and there's a way to interpolate things. With this, you have to be careful, of course, and it depends on your scientific question, what kind of things you can do with the data, and usually it's better to interpolate, of course, in some clever way. And these big gaps is maybe not the best the best thing to work with. But pandas allow you to do some quick interpolations that by default will look like this. And then you can have some, you can look at the methods that are available for you, linear time index path, and so on and so forth. Some crazy ways to interpolate your time series. And you can do like a little bit more advanced cubic interpolation. I don't see any big differences actually here, but yeah, so there is a way to interpolate your data as well. That's what I wanted to say. Okay, we're almost done. There is the last thing that I wanted to show you, this X-array. And if there is no very urgent questions, I can just continue and finish the presentation with X-array. Okay, doesn't seem to be the case. Yeah, just another, well, 10 minutes, I hope. But this is, again, the package that is super useful for people who work with two-dimensional data, especially with model data or satellite data or everything that is actually Netcdf data, Netcdf type data. An X-array allows you to do many things. I'm not going to cover all of them. Most of the things I would just show mostly the plotting, the way how you can use X-array as the data exploration software, but it's also allow you to do some very efficient multidimensional analysis, do out-of-core computations, and so on and so forth. It's super powerful, but I've just touched the surface of it, right? So if you want to work with Netcdf data or some data that fall into the category of the Netcdf type data, HDF, for example, or some images even. X-array can be also described as the merge between pandas and Netcdf, sort of. So you can open the data, the Netcdf data in X-array like this. So again, clear the output. This is again just a pointer to your file. But there is a much nicer way to look at your data. Already you can see that you have longitude, latitudes, longitudes, time, but no data is yet loaded. Right, here's your dimension, here's some attributes, and that's an actual data. You can look at this air data variable, and you see this is its coordinates. There are some attributes that are actually can be looked at as well, and you can immediately plot it. Right, so that wasn't something that was available in our previous Netcdf 4 library that we use for plotting the data. You can just plot the data, and it will use latitudes, longitudes. Of course, that's not a map because there is no projection applied to it. Or it's a very simple projection, I would say. But yeah, you can plot it, look at it straight away. What I did here, I just select the first time step again. And this is this square bracket syntaxes that you can apply. You can actually use Cartopy functionality with X-arrays. And for this, you have to import this Cartopy CCRC, and then you can plot your data immediately on any crazy projection that of your choice. What happens here, again, we just create the axis for Cartopy. So this is just basically your projection. You can think of it as just a projection. Then we plot our air. Again, look how many points I have here, because that's very convenient, right? We say file. I would like to select the air variable from this file. I would like to select the first time step. this is alternative of here to using this zero column thingy. You can just say, I want to have something from dimension that is called time, and the zero index of this from this dimension. That is sometimes more understandable for people. I would like to plot. I would like to plot with contour F, and I would like to put it on the axis which understands the orthographic projection, and transform plot Curie means that my data are actually in geographical coordinates. And I would like to overlay coastlines. So 3 lines of code, you have a map. Same here, same thing with the Mercator projection. We just change here the projection to Mercator. North Pole stereo, no problem. You just have to remember that you have to set extent here, right? Again, this is all working with X-array. Just the selection of data is just happening here. What else? Next things that I show here, that you can provide some levels, provide some color maps. This is just saying that the projection can be here, and then and again this is transformed. There's a question: where does the color bar comes in? The color bar actually, well, this thing created by default. The color map you can specify. How to control the color bar, I'm not really sure. How easily it is done with X-array. What you have to also understand that this is designed for quick looks, right? So you don't have to use it for your publications at the end. I mean, you can try, but better to then, after you look at your data, then create the proper maps with Cartopy. But this is just allows you to quickly look at the data. That's why tuning of the color bar, let's say, maybe is not something that you want to do at this stage. But color map is provided here with contour F. CM seismic is the CM is collection of color bars that comes with Matplotlib, and it's imported here, right? So this is how you import it from Matplotlib. Import CM, and in this CM you can look at the selection, a big selection of color bars. Yeah, so that's the bunch of color bars that are available for you, and there are other packages for Python that gives you much more, much bigger variety of the color bars. What else I wanted to show? Okay, you can create the variable air mean that actually convert from Kelvin to degrees Celsius. You say, okay, F, our file, air, our variable. I would like to make a mean over dimension time, and I would like to, from the result of this thing, I would like to subtract 273.15. And what we will get here is this. Yeah, so it's again X-array dataset that can be then used to plot the things, right? I'm not really sure how to fight with this line in X-array, but again, this is just something for you to have a quick look, not something that you probably have to use at the end for production. Okay, this is just the last thing that I wanted to show finally is that you can select actually some data from some specific point. But again, for this, you don't have to know the indices of this specific of some particular latitudes or longitudes. You can say, I want something that is around longitude 5, around latitude 87. I want you to find it by nearest neighbor, and the tolerance 5. I'm not really sure what it is. Have to look at the data at the description, but I think it's how far away your nearest neighbors can be to your point. But this is just the closest point to the points that you actually ask for. This is super convenient because you can just select the points very easily without knowing exact locations of your how they are done with the data. And the last thing that I wanted to show is that you can actually save this result into the point variable and then save this variable as netcdf. And to save it as netcdf, you just say to netcdf. That's it. That's the only thing that you have to do. And you will get something that can be viewed in MC view without a problem. The dates are here, the values are here, the metadata are saved, right? So, and this is a lot of metadata actually are coming together with this file automatically. So that's the beauty of Xarray. One of the things. I'm just really advise you to look at the Xarray documentation and see what it can do for you. It can do a lot, and very nice. How to save the fix? The easiest way, just let me try. Just say plt dot save fix png. Let's see if it's gonna work. Yeah. Well, I mean, it's not. Yeah, I would have to cut it. I mean, you have to have a look how to do it properly. The problem here is most probably is that I specify the figure size and not in an optimal way, so you can play around with this one so that your figure at the end looks better. The safety. Well, and of course you can always cut it. It's also pretty easy. In different resolution. Okay. Different resolution can be set by DPI equals 600. If you think that you're gonna put it on some very big, I don't know, poster. Yeah. So it's very, very high resolution now, believe me. It is possible to remove the color bar. I think it should be possible. You have to look at the plot functionality of Xarray. That's pretty big, yeah, pretty big package. Should be possible, but I'm not really sure how to do it. Yeah, thank you very much for, like, I mean, you can continue to ask questions. I will be here for another, like, 10 minutes, but I will stop recording now. And yeah, thank you very much for participating in this and hope you enjoy it. Maybe see you next time in some other lectures. Bye-bye.